So hi everyone, welcome to the last session. This session is devoted to panel discussion, and I have the pleasure to chair this panel. So I'm Begum Demir, I'm the head of the Big Data Analytics for Earth Observation team at Bifold. And today we have 4 panelists, and we will be discussing on opportunities and future works in terms of data management and machine learning for Earth observation. And now I would like to ask to our panelists to very shortly introduce themselves.
Okay, so moving from here, I'm Paolo Gamba. I'm professor at the University of Pavia. I'm currently the editor-in-chief of the IEEE Geoscience and Remote Sensing magazine. I've been the president of the IEEE Geoscience and Remote Sensing Society, and I guess I'm the oldest guy in the room.
All right, hi everybody. I'm Hannah Kerner. I'm an assistant professor in the School of Computing and Augmented Intelligence at Arizona State University in the US, and I am also the AI lead for the NASA Harvest and NASA Acres programs, which are NASA's agriculture and food security programs.
Yeah, so hi everybody. It's very nice that you still stayed to this very last part of this nice event. I'm Ronny. I'm really happy to be here because Berlin was my academic home for 17 years, from 2002 to 2019. I did my PhD at the TU Berlin, not with Begum, in another group. And then in 2019, I went to the German Aerospace Center, DLR, in Munich, where I'm still am, working a lot on computer vision, machine learning for synthetic aperture radar data. Similar to Paolo, I'm also very active in the Geoscience and Remote Sensing Society, where I'm now the current editor-in-chief of the Geoscience and Remote Sensing letters. Before I was the membership chair, editor of the newsletter, and chair of a technical committee on image analysis and data fusion.
Okay, so hi, I'm Ribana. I'm the head of the Data Science for Crop System group at the Research Center in Jülich, and also I have a professorship at the University of Bonn with the same title. As you have seen, I work mainly on the explainable machine learning for agriculture and environmental sciences, now also on data-centric machine learning, so everything related to how can we get actually data out of our data, or value out of our data with machine learning for specific relevant applications. Yeah, I'm active in the ISPRS community and the IAPR, the International Association for Pattern Recognition. Yeah, that's it.
Thank you very much. So I have prepared some questions, and I will be starting with my questions. And then close to the end of the panel discussion, I also would like to ask you if you have any questions to our panelists. Okay, so then the first question is on AI for EO. So during the last years, AI for EO has successfully evolved, and many methods, systems, algorithms have been developed. So now, what are the emerging successes and impacts? What we can do more? I would like to, is there anyone who would like to answer this? What we can do more?
Here, maybe I can start. So what I really like to see, and we saw this in this workshop already a lot, is that Earth observation data is more and more used in actual applications. It's not just an academic exercise anymore. We have AI in operational services, in space agencies. There are more and more companies that are using Earth observation data as well as machine learning to derive their products and so on. So this is really showing that it's really working and has a societal benefit. So this is this one thing that I really have seen developed over the last years. On the other end of the spectrum, what I still see in mostly academic worlds are those academic silos of groups and whole communities, still applying a couple of million model on a single image for training and evaluation, getting 95% accuracy, and writing papers about it. And if you read this with a machine learning expertise, you know this will never be able to be deployed in any kind of practical scenario. So I think there we still need to evolve as a community to make clear that this kind of like purely I mean, it's not even academic because it's purely wrong, right, to do it in that way. So this is that we are more and more moving away from that. I think there we still need to improve. Already a lot of groups are going away from that, but there are still a lot of groups doing that.
Yeah, I agree with that. And I think there are a lot of wins that we could showcase of where these models are actually being used in real applications. But I agree that there's a lot that's in the literature. Even there's certainly this whole population of the problematic studies that are just like not even doing rigorous evaluation and things like that. But there are a lot of potentially promising methods as well that are doing rigorous evaluation and everything, but the gap between evaluation and presentation in the paper and deployment in real solutions is still so far. And I think, especially for deep learning, like the uptake in real use cases or the outputs of these models being used to answer these actual questions that people have, not just make the output or the proof of concept, are still extremely limited. And in things like, I think a lot of those examples that Noel shared earlier, for example, or in a lot of these applications that you might be thinking of where models are used in practice, things like Global Forest Watch, Allen Coral Atlas, a lot of these different kind of flagship decision enabling systems are using random forests and decision trees. Deep learning is hardly being used in deployed settings. And even for those products, I think there's the ones using random forests across the board, it's not just deep learning, but I'll say especially deep learning, there's huge limitations that we need to address that people have talked about today as well, like poor generalizability, taking a long time and a lot of labeled data to develop these models to work for a very specific area, poor evaluation, so we don't really have a good sense of when these maps are being published, what the expected accuracy even is, or how we even define accuracy. And I think there's, a lot of opportunities that we have to study more interesting questions too than just like making another land cover map. Like I would really not like to see more global land cover maps, because I would rather see people taking the areas where they're all doing really poorly and making things better there. Like, despite being a very optimistic human, I'm really most interested in worst case performance in a research setting. And I think we don't talk enough about that as a community.
It needs a second. Okay, that's too fast. Yeah, I actually totally agree with it. So, for example, when thinking of about generalization ability, so you see all this global map spread for us is actually in agriculture. We go to the next field or to the next year, and the model is not working anymore. You can even say it's local. I think I already said it. I think we have a lot of really good machine learning models and a lot of good frameworks, and we are also able to use it, but we also need to think about how we combine it with the data. So I see it's actually also what Hannah says. So we go to the areas where it's not working well, and see what you can do there, and maybe we need a new method, maybe not, maybe we just need better data, but oftentimes we cannot even answer this question. So I would like to see more research in this direction where we think about the whole machine learning cycle, including the deployment, including the data curation, the modeling, hyperparameter tuning, everything. But we need to think it together, and also together with the domain scientists, because it was also said, sometimes we ask the wrong questions. It still happens to me that we do something and then we think, oh, we have a great result, and we present it to the plant scientists and they say, Yeah, but it's nice, but that's not interesting for us. There's a different thinking of what is important for the field. So, yeah.
Yeah, I mean, that's a good point. My opinion, people who know me know that I used to say that people in remote sensing are a community of communities. But it's actually true for any type of world of areas like this. I mean, if you talk about artificial intelligence applied to remote sensing or Earth observation in itself, you have many, many different people like most of the people here who have a background in computer science. They know very well what we are talking about when you speak about models. And people who are actually just using the model or would like to use the model and do it for something which is useful to them. And that is, I think, so the next big thing, I would say, in terms of, because right now AI has these exponential curves in terms of publication, in terms of models, in terms of, but it doesn't have the same thing at the level of application, as far as, I mean, everybody knows the fact that, I mean, there is no, most of the things are, when you go to the application, they are lagging behind. That's true in telecommunication, that's true also here in computer science, and many things are based on random forest, still on random forest, which I know Ronny is a fan of random forest, so I'm not saying anything else against, but you know, you have seen, I mean, it's something that was, let's say, at the forefront a few years ago. Now people are talking about something else. So just to tell you, I think that Noel today mentioned democratization or something that is spreading out the information. I think that education is my take of that part. I think we need to have some very strong education in terms of what AI is, how it could be used, not only the technical thing, but also the non-technical thing, which is very important.
Okay, so thank you very much. And yeah, we have heard different talks on foundation models. And do you think that foundation models can help to address these challenges that you are mentioning? Or what are the new research and developments needed to advance the existing foundation models in remote sensing? Because we see that there are several already published, but there are many more are to come. So what's your feeling about foundation models and how to advance them?
I think similarly to the last question, there's a lot being published, there's not a lot being used. And if you have a huge model that is going to be extremely difficult to reproduce the results from and access, and like inference is going to be expensive, fine-tuning and inference is going to be expensive too. Like for a lot of these models that are based on a VIT large, in particular, if you, sure, like training is expensive and that's already been done for the pre-training, but to fine-tune, you need multiple GPUs. That's not very accessible. That's not really what we're talking about when we're saying like turning this deep learning into cheap learning. That's very expensive and is going to especially be expensive at inference time when you need to apply that across the whole world potentially. So we really need to think more deeply about our architectures and how we actually design these to be more efficient. I think to Ribana's point also about data-centric learning, we need to think about what the models are being trained with and how that affects the model. So something we're studying a lot in my group right now is this concept of data model efficiency. So suppose we have a very large model with uncurated data, which is kind of the status quo right now. Can we achieve similar performance with a small model but a curated data set for pre-training? So maybe we can optimize where we select the data and the data composition to increase the efficiency of our model at learning from that data, so we can, you know, get more gain. We can, so far, we'll have more on this soon, but we see performance increases of like multiple percentage points, maybe much more, just based on how you decide to stratify your pre-training sample. So where you choose to draw the samples from, and that's free. that's much better than increasing the capacity of your model in terms of compute.
Here, regarding foundation models, I think the point I made before about the evaluation becomes even stronger for foundation models because a couple of them are around. I talked to a few companies who were trying to use them, and they said doesn't really work for our applicational use case. And before, for the standard case, you know, where we have like one specific sensor connected to a specific task you're interested in, you have a method developed for that. Even there, you had the problem that it's up to you to choose the benchmark data set you want to evaluate your method on. It's up to you to choose reference methods you compare against. And you will never know. If I write a paper, I have 4 benchmark data sets, 4 reference methods, you will never know that those are the ones where, you know, my model shines, and the ones, you know, where my model is inferior, I reject. Now with foundational models, we add another degree of freedoms, because now we also can select the suite of downstream tasks that we are evaluating the foundational model on. So I think what is really, you know, even more important is that we have a rigorous protocol how to evaluate deep learning models in general, but in particular foundational models, so that we can really have a fair comparison with you know, comparable data sources, comparable downstream tasks as well, and maybe even compute resources.
Yeah, I also just want to like put in bold and underline evaluation from Ronny's comment that like we actually do have benchmarks of multiple tasks for foundation models, but who chooses to use them, you know, if somebody's putting something in a paper, publishing their own model, maybe it's not favorable across all those tasks, well, that's up to them to cherry pick. And it's not really clear like whose responsibility it is then in this community to do the evaluation. And maybe as benchmark evaluation data set developers, we need to at first be evaluating all of the models, and then it will start to gain as a practice, but it's not really clear how we get ourselves as a community to do these standardized practices like are done for LLMs, for example, evaluated on standard evaluation tasks.
Yeah, I can totally agree, and I want to emphasize once more, what I discover at the moment is everybody is thinking about the quantity. It's just more data and even more data, and then we think about, oh, now we have so much data, what can we do with it? But that's the non-experimental data, but we still rely in a lot of scientific applications on experimental data, so in situ data or labels and whatever. So I think it's important to always think the foundation model together with the downstream tasks. So, and not only thinking about how to get a good foundation model, how to get more data, quantity. We have no idea how to get a foundation model unbiased, for example, so or how to measure a bias in there. Not yet, but I think these are all important research directions to think about how how can we actually find something really generalized and so general that we can use it later, not to do any harm to our downstream tasks. And I don't see this. At the moment, it's just I only hear the foundation model, not foundation plus downstream tasks.
Okay, so we mentioned that it is time demanding to prepare the data as an input to foundation model. So the data is there, but to prepare the data is very time demanding, and also then we need infrastructure, very good infrastructure to train this model with large amount of data. You mentioned that you are researching on finding a proper, smaller data set that can allow to address these issues. But are there any other solutions that you can suggest to researchers, scientists in the room? That's a very tough question, I know.
All right, so that is a very subjective and personal view. So I won't work or I won't research on foundational models. That's my sustainable approach to that. Not because I'm saying they're not important, but I don't think that the whole community needs to do the same thing. So it's completely fine if groups that have access to this infrastructure, like with IBM or NASA or ESA and so on, or the Jülich Supercomputing Center, that those groups are focusing on foundational models. Completely fine with this. It's an important part of research, but I don't think that everybody needs to do that, because basically we're going back to the era of shallow learners, where we had a feature extraction, then we had a feature extraction, feature selection, then the classifier, and then some post-processing. So basically a foundational model is giving you a feature, an embedding of your data. And then in the downstream task, you need to do something with that, right? So there's a lot of work to do after the foundational model gave you this embedding. So it's completely fine. There's a lot of space for everybody to focus on those problems. So you don't need to be worried just because you don't have access to this big infrastructure, this high compute power, that you will be out of place and you can't compete with those groups. My message would be you don't need to compete with them. You can build upon the work they were doing and think about clever ways to leverage this embedding for your own research. Might it be applicational driven, how to use the embedding in your specific application, or maybe even machine learning, computer vision driven, how to use this smart feature descriptor for your own, random forest, for example, or whatever you want to do, deep learning, or whatever. So, well, it's not really a solution how to do it sustainable, right? But the punchline is basically, I don't think that everybody in the science community needs to do the same thing just because it's a hot topic and a really relevant topic. And
the community can be doing that evaluation also, right? Not just like, oh, this must be good because it's out there and whichever tech company published it, but how well does it actually work, right? We see that with natural language processing and vision models. Like there's a huge field of research now on just using those models to test how good they are for different tasks and, complain in a good way about what needs to be better. So I think we definitely need that. And also, again, just don't assume that you need a VIT large because that's what's used in other masked autoencoders, for example. Maybe try smaller models or think about the nature of the data that you're trying to learn from. What would make sense for remote sensing data in particular. It's not even clear that VITs are the right architecture, right? It basically came from, we have transformers that work really well for language. How do we make it work for vision? Let's chop this image up into tokens, right? I'm not sure that that's the best thing to do either. So, we need to think about what architectures might make a lot of sense for remote sensing data in particular.
Before moving to the next question, I would like to ask to the audience if you have any question about foundation model in the line of this discussion at the moment. Maybe it's timely.
Cheers. Thanks for that discussion on foundation models. About the topic of downstream tasks, I'm just wondering, so you touched on the topic. Do you want to dig into that a bit more? Because it'd be interesting to know how you classify it, how you classify those downstream tasks. Sort of what's the abstraction of those? Are we talking about segmentation, those kind of tasks, or are we talking about more application-specific downstream tasks? And is there a roadmap for the research community that someone's published? Maybe there's a survey paper you want to point to.
So I can not talk about the satellite data, but I can talk a bit about discussion we had about UAV images and ground robot images, but I think it also applies to satellite images. So we don't know. It's actually, that's the thing. We don't know yet how to define our downstream tasks. For example, do we go for the machine learning task, or especially, for example, the phenotyping task? That means nutrient deficiency or detecting diseases or growth modeling, something like this. We don't know yet. Maybe it's good to, I mean, if you have broader tasks, you have more data, but maybe it's too diverse and it doesn't work quite well. So maybe we need especially very, very accurate, specific data. But this is something where I think Hannah mentioned it, we need to evaluate it. We need to see how it works. And I don't think we can already draw conclusion from one community to the next community. Yeah, the short answer is I don't know what we should find out.
I think from the model developer perspective, we actually do know what tasks, there are a lot of tasks that we could evaluate on. I think when you're looking at specific communities, I totally agree that like that might be harder to identify what all those use cases are for phenotyping and things like that. But like for all of these papers that are saying like, oh, here's our foundation model, go forth and use it. You know, like there's a lot of tasks we could be evaluating on. There's a whole bunch of standardized benchmark evaluation tasks that come from the literature that we can use. For Presto, we evaluated on like 10 different tasks in classification, regression, segmentation, from things like algae bloom detection, crop type classification, flood segmentation, tree type classification, all kinds of different things. And we also have we published a benchmark called GeoBench last year that has maybe 10 also very diverse tasks that we specifically designed for benchmarking self-supervised and foundation models and having a leaderboard for that. So I honestly feel like we have no excuse to not evaluate our models using a lot of these. I think if we don't see people evaluating them, then maybe there's cherry picking, but also there's maybe those benchmarks are not as accessible as they could be. I'm not sure, but I think we're just doing a poor job as a community at evaluating.
I'm adding something from the point of view of an editor of a journal. I mean, in the past, what happened is basically that it was the peer review that was giving you the evaluation of your methodology. And we are shifting a little bit towards the fact that you have some objective data set that you use in order to obtain some numbers, and then those numbers give you the idea. I totally agree that if those numbers correspond to very different tasks, they give you a general, let's say, overview. I still think that for some of the evaluation, which is not a purely quantitative evaluation, we still need a community work together. And I think that this is the reason why it is important not only to publish in itself, but actually to go through the communities in order to be able to show, to understand, and to make, or let's say, collect questions and eventually provide some answers. That I think is important because, and this also means that I think that it gives something to every one of us, because in the past it was basically, we could say, okay, you receive email asking you to review papers, you say no because you're busy. That's wrong, because basically this is the way that you help the community, and when you submit a paper, someone else will review it. Now, you can think the same in terms of your model, your idea that you publish somewhere, feel somehow obliged to do some sort of evaluation of the other models, not only because it will be useful for your career, your publication, and so on, but also because this is a community service. I think that is something that is, I mean, we need to think about that.
Like machine learning journal or machine learning conferences, at least if you're not comparing to other models, you will not be accepted. So I think it's also up to the reviewer community to keep that standard of evaluation in mind.
Very much for all these nice comments. Is there any other question from the audience on foundation models?
Thank you. So we talk a lot about foundation models. It's a very attractive topic right now, but we also need to consider, I think, the climate impact of training these sorts of models, especially when we consider that random convolutional embeddings kind of get relatively similar performance to foundational model embeddings. So I guess, do we have any thoughts on how to approach that? How can we get to the next level of remote sensing machine learning in a climate-friendly way?
Again, I would say if you're working on a task, like when you choose the tasks that you're trying to optimize, if there's a task that is getting like 98% accuracy in a real evaluation that we all agree is rigorous and using random convolutional features, then like maybe that's not the one that we want to focus on optimizing, right? Again, like there's so much focus on these kind of solved tasks, and we need to be talking more about the areas where we can improve on things that are not solved. And again, I think there are a lot of use cases where random convolutional features are a great baseline for remote sensing tasks where they aren't actually that performant, but they're better than a vision transformer model, let's say, or a pre-trained model on ImageNet or whatever. And I think that's where, again, like we need to be designing better models that take advantage of, like actually try to learn the unique patterns in the data. That's a great baseline to use. But if we're not doing better than that, maybe that wasn't the right solution, right? So we can come up with other things, maybe even that use random convolutional features in there instead of learning convolutions, for example.
So my thinking was also a bit, we need to start tracking our computational energy and everything what is needed. So I can tell from Jülich, they just recently started that you can actually ask how much energy was used by computing your model. So before we asked, and there was just when this the name green AI and all these the terms popped up, and we asked, and they said we don't do this. And so now they started actually, and I mean there is the supercomputing and they should do it, but I think a lot of us, including me, I have no idea how much a computation there actually costs and energy and money. And I mean, money is maybe not the main problem, but the energy. And so we get some feeling, a better impression on how should we retrain it? Should we learn something new? Should we wait? And I think this is where we should start. I don't know if everybody or if every computing center does this.
But even in some machine learning conferences, you're either required or strongly encouraged to report in your metrics like GHG output and training time, like all of these things that are related to those factors. But that only goes so far in like those one journals, right? So if that becomes more of like a standard metric to report in the community, then maybe that would, and we value it highly as a community, right? Like GHGs are more important than 0.001% increase in accuracy, then that won't be prioritized.
That's really good. And I'm really curious how long it takes that other communities would take this up. So it would actually be good, but I think it's our task because we all work at the interface, right? So it's our task to get such things in the more application-oriented journals and start reporting it. That's a good thing to do.
Maybe even because like in machine learning conference reviews, any of you who review for these, you know that there's like several questions, right? There's prompts to fill out Whereas in journals, typically it's just open-ended review. So maybe if there's more prompts in the reviews, editors.
Well, sure. I mean, that's really real. The real thing is that it's different, of course, reviewing a different paper in different journal, but it's also because you have a different community which is expecting you to do something which is different. I mean, if you review a paper which is about AI applied to, let's say, the definition or extraction of the biomass, it's really something that makes, I mean, you're thinking whether you have to think about the methodology, which is the AI approach, or the result, which is the biomass extraction, which is then fits in something else. So if you talk to people who are working on biomass extraction, they don't care how much you use, I mean, on that AI model first, but more on the fact that you are basically obtaining a better result. So the reviewer will be biased. And again, that's again, in my opinion, the reason why it's basically good thing to have, if you have something as a paper or associate editor that's managing this paper, you should be able to have different point of view on the same paper. I think as opposed to have just people working on AI for computer science or people only working on the specific application in this specific type of papers. I mean, and I understand that when you publish a paper in a computer science conference, you expect people to evaluate the computer science part of your work. But if you publish, for instance, at IGAS, just to give you an example, which is a conference on Earth observation, you don't expect people to basically understand or be able to evaluate completely your AI implementation and things like that, because it's a different community. But you still could publish more or less the same paper in the two different areas. So you need to be, the fact is that we are, as someone said, at the edge of an area which has very fuzzy boundaries. And I think it's very good, but it also requires more effort in order to be able to do a proper evaluation.
Okay, yeah, in the line of this discussion, I would like to ask, since we have two editors here as panelists, I would like to ask if GRSS is considering how to approach to these concerns related to reproducibility. Because we mentioned that if the models are large, reproducibility is challenging in general, but also in particular, that we have some concerns about reproducibility of the works published in remote sensing. So are GRSS journals considering this issue and have a plan on this?
Starting, okay. So yes, I mean, there is a plan. It's not easy to implement the plan, so we are actually starting to do that. I mean, it's clearly the fact is that people who usually publish on our journal, meaning GRSS journal, they are not used to provide the code, they're not used to provide the data because of historical reasons. We are pushing towards the direction of having everything available by means of specific data repository. We are trying to change also that from the IEEE point of view. They want to go to this thing which is called data port, which is not fine. I mean, I'm at the moment, don't quote me on that. Okay, we would like to have open repository for the data, and also for, of course, takes a while to steer the whole community, also because, as I mentioned, you have different type of communities, people publishing in our journal. So it's a struggle.
Just to add to that, so yeah, authors are encouraged to provide code as well as data together with their paper submission. IEEE tries to link this, of course, to their own service, like Dataport or CodeOcean, but authors are free to also, put the code on GitHub or whatever. So yeah, they are encouraged, and in principle, we as editors could make this a hard requirement. We could say, in order to publish in our journal, you need to have this public. But that would not be a solution to the problem, not even a good one. It wouldn't be a solution at all, because if the community is not used to that, they will just go to another publisher, right? If we make this decision on our own, it would not lead to more reproducibility in the community. So what I think this can't be a top-down thing, it needs to be a bottom-up process. So it needs to be the community that understands that if you want to have reproducible results, you as reviewers should reject papers if they are not publishing the code and the data, or at least, like, I mean, data is a little bit problematic. Sometimes you can't publish, but at least you can run your method on your private data together with on a public benchmark data set, right? But it needs to be the community that is enforcing those standards. It can't be a top-down process.
Just to add a comment, because someone, I think yesterday, there was someone mentioning the fact that GRSS at some point has this remote sensing code library, where there was the possibility to submit your code, and the main reason, and it is now over, the main reason is basically the fact that you need to have a corpus of reviewers who are able to run those things and to understand. I mean, reproducibility means that someone is trying to do the same thing and obtaining the same result, but is not the author or a friend of the author, someone else. And the typical reviewer, which is reading the paper, is not able or not willing to do the fact that download the data, the software and try it and find if it works it gives exactly the same result. Because we are not used, because it's difficult, because sometimes it requires that you have a specific type of software, specific type of whatever on your computer, which is not what you have. So this is something that, as Ronny mentioned, it's not possible to impose in a top-down fashion. You need to do from the bottom up. And it's up to us to change or steer this big thing.
Do you think that there is some maybe softer middle ground, though, where, to give an example, like I think it's AAAI, but many other conferences do this, but where in the submission form, so when you submit it, there are questions that you have to fill in something for that's like reproducibility checks. And you have to put like, is your data available? If so, where? Is your code available? If so, where? You know, ask these things. And then in the review form, there are questions also about reproducibility. Nobody's saying what's required. You just have to answer the question. I'm not a psychologist, clearly, but I feel that just like making people have to explicitly respond about it helps to influence that culture. Because people will be like, oh, should I? Maybe I should put this here if it's going to be part of the review. You're not saying it will be rejected if you don't share it, but it gives you a mechanism for evaluating it.
Yeah, that's what I meant exactly with the bottom-up process, right? It needs to come from the community. You as an author are free to submit your paper on private data with private code, but you should have the feeling that probably the reviewers will reject it if you do that, right? It's not a hard requirement, nobody's forcing you, but you do know the chances of being accepted are decreasing significantly if you don't follow this community standard, right? So this is where we need to arrive in the remote sensing community. I think we are on a good way because a lot of people are already doing that, in particular those people who are working on the intersection between Earth observation and machine learning and computer vision. But it needs to spread out a little bit in the other areas of the community as well.
Yeah, and generally speaking, the fact is that on the same journal you have people who publish, for instance, how the new sensor, which will be on the Sentinel-2 next generation, is working, and what are that is something which is completely different from computer science. There is no code, there is nothing. I mean, so it's not that you could force everybody to do the same thing. It's really depending on the type of community that you are using. That you are addressing. And since there are a lot of different communities, it's good to have something that requires for people who are used to do that, but it's difficult to force people.
I agree, but because I think the other side of that is that it's really challenging to get the qualified reviewers from that pool for a very diverse set of papers. So maybe if there's a question that somebody can just write not applicable, if it's not applicable, then it encourages people who are reviewing it, maybe don't have the full expertise, but it gives them a way, maybe a tool for doing those checks too.
Okay, yeah, great discussion. I would like to change a little bit the direction now. Paolo, you mentioned about Sentinel-2 next generation, and I know that you are a part of the development of Sentinel-2 next generation, and please correct me if I am wrong, but with this next generation, the aim is to improve the spatial resolution, right?
It's not only, I mean, it's basically also to improve also the spectral resolution. There are additional bands, and also there will be bands which are, let's say, moved a little bit in order to be exactly or very similar to the bands of Landsat that I mentioned earlier in a discussion, that there are the two things which we try, NASA and ESA are trying to put everything together in order to be able to work on this on this joint data set for the future. So there will be double, let's say, at least, I cannot say that for sure, but right now the idea is to have 5 meter spatial resolution on the best, or on the finest. So it's 4 times, let's say, the data, and you will have more bands in some areas which are more important. That gives me also let's say the occasion, let's say, to say something about the fact that when people are deploying or thinking about a new sensor, and it's very interesting to be there at a discussion, because you see people who are actually working on very specific tiny ideas of, okay, I want that specific band because it's useful for that specific thing, like chlorophyll A or chlorophyll B or whatever, which is important. And then people who are working on other ideas and it's very important to understand that in general, when you have the data which is what we start with when we talk about evaluation of the data, it's already a sort of compromise trade-off between many different communities, many different people. And this is, I think, is very important and very relevant, because in some specific approaches we expect to have, and I think that in general we expect in the future to have data which is, let's say, standardized, somehow standardized. For big satellite and for small satellite as well, I should say, this will never happen. Okay, you will ever have some specific slight difference between one or the other. Just think about the fact that you will, so far we were not able to obtain data which has the same format from different satellites. Despite CEO's efforts to do that, everybody is doing their own way. And this is just a thing which would help a lot if we had something already which is already in the same format. But it's not there because of many different reasons. One of them is back compatibility, which is good anyway. So I think that, so thinking about the future, we will have a number of satellites which are continuing our, let's say, ability to cover the planet, both in the optical, of course, SAR, there is also Sentinel-1 next generation, Sentinel-3 next generation, and more. And I think it's very good that we have this capability for the next few years.
Exciting. So, so the spatial resolution is really very important for some specific applications, and temporal resolution is important for some other specific applications, spectral as well. But we were hearing different talks on to reduce the computation complexity. The models can be trained by using on the spectral content, temporal content, ignoring the spatial content, for example. What's your opinion on it? Should we ignore the spatial content while modeling our architecture? Ask your opinion on this.
My first opinion, okay. I personally think that, I mean, again, it really depends on what is the type of approach, and it's basically, it depends also on the spatial resolution that you are considering. So if you're basically just thinking about cauliflowers and you want to do something which is very important, I mean, of course, you cannot have anything meaningful if the resolution is not high enough, even if you have a very fantastic temporal resolution. Maybe something is in the between, but I mean, that's the point. So you need to have both for specific application. you might have a situation where you would like to have more temporal, you don't care about spatial resolution. I think people working on ocean or things like that, not all of them, and specific middle of ocean, let's say, not coasts, and other things. But again, it really depends. And the data that we will have is basically, again, a compromise between many things, including the money, which is does ask to our European governments, okay, and they sometimes say no for this thing, yes for that other one, for political reason, not for a specific scientific reason, and that eventually is the fact, for instance, that Sentinel-2 next generation, we thought about having 3 satellites as opposed to 2, which is now, but no way. The money is limited, so it's not possible to have it, which would have been improved a lot in terms of temporal resolution as well. And of course, everybody knows that if you want to have a better temporal resolution, you have a fly to lower orbits, but to lower orbits, then you have the problem of the fact that you have slant view, and therefore you have all the problems, for instance, for vegetation and urban areas as well, problems on the mountains and so on and so forth. So again, it's a big amount of trade-offs among the different communities who would like to have this data or the other data. Please think about the fact that, of course, when there is some sort of application, you need to find out first if the data that you have is good for that specific application. I think that's one of the important things, because I mean, it's very easy, and we see it as a number of papers that come, and they just put this block, this block, this block, we apply to that data, and we got some result. Does it make any sense? Sometimes no.
I also totally agree that the data you choose to use depends on the use case. For creating a foundation model or a model that we wanted to be generically useful for a lot of different tasks, we again had these trade-offs of like computational complexity, which sensors to include that are useful for most use cases, what resolution to harmonize them all to, what temporal frequency to use, all these different trade-offs that basically we determine based on the use cases that we want to be able to serve. And so, yes, there are some use cases where spatial context would help. And again, I wasn't talking about spatial resolution, I'm talking about the context. So being able to have like a patch input rather than a single pixel, because we still do make predictions on every pixel to get a map, for example, at 10-meter resolution or whatever the choice is. But, you know, across most of help you that much. It's not worth the added parameters that you have to have when you add convolutions or when you add a spatial dimension. I mean, certainly there are ones that it is useful for, and so we're also exploring how we can add some spatial context without exploding the parameters. But it's a research question.
Very timely and important research question. So now I would like to ask to the audience if you have any question to our panelists. There's one question here.
Thank you very much for this very interesting discussion. So one topic that appeared quite often these 2 days was down of deployment. And I guess the reason why not all the models are being deployed in real life is because it's very difficult. Companies have entire teams dedicated specifically for this. So what would be your pointers towards how this can happen in research groups with limited resources?
So one point you could take is that as a researcher, it's not necessarily my task to deploy the tools that I develop, right? My task is to develop those tools and make a rigorous evaluation of their usability. But I don't need to found a spin-off then, to commercialize that. That might be a task of another group. But the important part is that I make sure that there is this connection. So one thing you can do as a researcher is to include the stakeholders of your development already into the development process, so that you make sure that the target variables you're addressing, the accuracy you're achieving and so on, are actually relevant to the end users, to the stakeholder in your task. You know, again, it doesn't mean that you need to be the one who's then, you know, really commercialize your development, but you should have the practical applications in mind when you do academic research as well. So this would be one way that even if you're just a small research group, to still make sure that your method's actually getting deployed. So deployment not necessarily means that you are the one who is deploying it. You just need to make sure that you're enabling the process of the deployment. Right? Of course, if you're a bigger group, bigger research institute, then having spin-offs, having patents and stuff like that are ways forward.
Thank you. Any other question?
Hi, I'm wondering with like this call to produce or to not stop after you have published the results, but to produce an application, and we've seen very good applications in the last 2 days. Where in the, or which community should be trying to formally verify some guarantees or provide some guarantees for these applications, because they provide like a real benefit for real people, for example, the flood evacuation, but how can you, or who should try to verify that you do not miss a spot on the map where there could be a flood? So is this, could this be part of the fine-tuning, or is this purely the application that's being then made by a startup, or can we have like some rigorous verification process that can tackle this problem?
So I think one, so I cannot really tell who is responsible for it, but I think as a researcher, our task is to provide as much information as possible that it's or that it can be deployed, or that it's useful for the application. So it's not only, or we should not stop at the machine learning result. That I totally agree. And we also need to think about what could be useful for the application. But for example, if you provide an uncertainty or reliability measure or an explanation or something else, I think we need much more of this information, and not only an accuracy number, so that others beyond, after you had all the results, can make use of it and really use what you research and what you produce. I think that's one important point, and I have the feeling that not so much papers and research provide everything or more than the actual machine learning result outcome accuracy at the moment. I think this would already help. It's only half answers to your question, but I think that's an important point there.
Yeah, I won't speak for who should be responsible in the community, but I will say from my perspective as a researcher and model developer, or my group as model developers, we feel responsible. I think it's our responsibility to robustly evaluate things. For example, like people ask us all the time through like stakeholders and NASA Harvest, like, oh, can you make a maze map for this place? Can you make this map for that place? And I'm like, do you have a way to collect data to evaluate this? That if no, then no, I won't make that map, because it can't be evaluated. It will be misinterpreted. This is just because I make the map doesn't mean that it's correct or that it's useful. And so to me, that responsibility is on us. I think there's many debates that the community would probably have about that, but to me, that's my like personal responsibility.
So now we are close to end, and I would like to ask to our panelists, if they can give a very short take-home message. Very short one. I mean, I know that that was not planned, but a message to our audience as a takeaway one.
So what I would say, and I saw this a lot the last 2 days, and I also told the organizers, I really liked the workshop so much because we went beyond the mainstream, that it was already said, not only producing land cover maps, but looking beyond what can everybody do more and what we need to think about. And I think we all got a lot of feedback. And my takeaway for me is think about what you can do more than just using a machine learning model, but go beyond with all what you have heard and continue to research in this direction.
Yeah, to build up on that, my take-home message would basically be science should not be a monoculture. We see this a lot with deep learning. 90% of the people are doing deep learning. If you submit a paper that is not doing deep learning, you get the review feedback, reject, because it's not doing deep learning. So I think this is really bad for science, and if we would have done that in the past, we would not have deep learning, right? Because, I mean, neural networks have been around since the 90s and even earlier. So just because lots of people are doing one thing, it does not necessarily mean that you need to do the same thing, right? It's completely fine to say one part of the community is addressing this topic, I do something else, and maybe I build on top of what they are doing, and I do my own development using that, right? Not everybody needs to do foundational models, not everybody needs to do XAI or whatever. It's completely fine to have your own niche and just think, what can you do in this aspect, and push the community forward.
My own thing is basically the fact that we need, I think that is basically what everybody was saying, that we need a way to evaluate our result, to do it properly, and to do it together, because we cannot do it at some point. I mean, you know that for people working in hyperspectral, there is this Pavia dataset with dataset which everybody is using. I'm saying that we shouldn't use it anymore. Do something else. But anyway, the idea is you need to have some ideas, and of course, it's someone that at some point, I mean, I'm pretty good to look at the different things that Anna was mentioning that could be our first set of things that everybody is going to use. And I think this is something that we would like to share between this community and the others community and the other community.
Maybe I'll end a bit more philosophically, that I think somebody said this in one of the talks, now I can't remember, but I think it's been said in many different ways actually, but we need to not lose sight of the actual goal that we all have, like what is our true downstream task, which is to take care of this planet better and to live longer for more generations, and to take care of each other, maybe. And I think sometimes we get our objective functions confused, or we have maybe shorter term optimizations than that long term. And so we need to keep in mind what is our end goal and how do we work towards that, not just optimizing for publication metrics or things like that. And I wrote a book that said to think about dying every day. And not saying that's what everybody should do, but in research, I think like we get so caught up, especially in machine learning, and this crazy race. And sometimes I just think like, well, what if we were to all die today or tomorrow? What would matter? And using that as what to prioritize, you know, what's really important here, and what can we focus on and not get so distracted.
Much. So thanks to speakers.